So graphs of sine and cosine, right, of the form y equals plus or minus a times the sine, and I'll just use sine to start. I'll do a cosine one later, of b times the quantity of x plus c all plus d. And we talked about this. We just didn't get to do a lot of the calculations, right? The plus minus is my reflection, right? A is what?
Amplitude.
The amplitude. And I've written them alphabetically because I want you working on them in this order, okay? Really, what is the amplitude? What could we call it? What's the simpler way?
The radius.
The radius. Nice. B is my frequency. I like to consider a point moving around a circle, just moving around a circle, right, at whatever speed. That's a frequency of 1. And then if I have another point moving twice as fast around a circle, right, that's a frequency of 2. So I like to think of this as speed. And then C is my horizontal shift or phase shift, right? So I call it the start. I want to think about where that rectangle that I'm drawing is starting. And D is finally
Midline.
the midline, which is my vertical shift, right? And when you read the textbook, and you should, when you read the textbook, their notation is a little different. But you should be able to connect, and their process is a little different, okay? But they're asking for the same things I'm asking for. So when you go do a problem from the textbook, you don't have to read their process. You can use the process I'm giving you, okay? It's not a bad idea to read their process, right? So our whole idea, right, is to think about that original mother function sine curve, right, in that rectangle. I'm thinking about that in that rectangle with the period, with double the amplitude, with the midline, with the quarter steps, and I'm going to move it, right? And so I'm going to be moving it depending on, or changing the dimensions of the box depending on the values of A, B, C, and D, right? Now let's take a quick look at a sketch. And I'm asking you, can you come up with a version of my sketch on Desmos? Now it's already there, okay? So you could go and search for phase shifts on sine curves in Desmos or GeoGebra. But I'm saying if you can actually get yourself to build it, right? So my program is called Geometry Sketchpad. It's not free, okay? You could open this file and look at it for free if you download the trial version of it. But you can't save anything. You can't save anything. That's the key. So, but we want to look at this particular sketch that I had built. But the challenge is really coming from, can you build it, right? Can you build it yourself? So here's my little control box up here. It's almost like I have a little XY axis, and I did it just this way, just so I could see the separate values of everything. So here I am. The original function sine is in purple, and the one that I'm going to create is in my blue box. And you can see I'm adjusting things and creating and changing this blue box. That's what I'm trying to get you to be able to do, is understand how the box changes, and then we can easily understand how the sine curve is changing or cosine curve is changing. So notice that I've set my A bigger than 1 here. So now my radius is bigger than 1, right? I set my A bigger than 1. Right, so A is almost 2, so you can see the amplitude, the radius is going up to a height of 2 and down to a height of -2. And certainly I could put A as the negative, and then you're just seeing that reflection of the sine curve. Is everybody with me?
Yes.
You're, Grace, thank you. Anybody else? Sean, you there today?
Yeah, I'm here.
You okay? You understanding what's going on? Michelle, you okay?
Yeah.
Brandon?
I'm good.
Okay. So as I change A, I'm changing the height of that box, right? Remember, the height of that rectangle is twice A, right? The radius up and the radius down. So really the diameter. Diego, what'd you share there? French fries?
No, I just saw Angel put like an emoji and I wanted to try.
Okay. It looked like McDonald's French fries. So A is an easy shift, okay? B is B is not. C is. What's happening to C? Look at what's happening to C. What's happening to my box here? Let me get A back to 1, okay? So, but now look at where my sine curve is moving. C is negative.
You're stretching it.
Okay, is the box getting longer? Or is it just moving?
It's just a shift.
No, it's
just a shift. And now when C is negative, why is my box moving right?
because x's behave inversely.
Nice. So and D, of course, is a direct. If I move D up, the whole box goes up. If I move D down, the whole box goes down. That's my midline, right? So right now my midline is about -2, and you can see that middle line in my rectangle is at a height of -2. Everybody with me?
Yes. Can you move B again?
Yes, I haven't moved B yet because it's the complicated one. I haven't moved it yet. I'm going to, but I got only 2 people with me. How about anybody else? We understanding how A, C, and D will move we did this transformation of functions already, right? So we're just doing it now. We did it with a 1-by-1 box, right? When we did all the mother functions. Now we're using this sine cage. I don't know what else to call it. So,
Welcome to the sine cage.
Thank you, Joe. So we're going to go back to the original curve and just look at what happens when I change B. Okay. Now, first of all, where's the value of B? Look at my function. Where is that value of B? Is it inside or outside?
Inside.
It's inside the function, so I know it's gonna affect things inversely. So meaning when I make B large, it's gonna behave like I'm compressing it. Okay. So let's just watch that. I'm gonna change my value to B. I'm gonna make it 2. And now look, notice the period. Where does the box end now?
At pi.
At pi. So it seems like I would have been multiplying by 2. But because it's affecting the x values, it's compressing by 2. I'm actually dividing by 2. And we've got this formula for our period, right? The period is going to be equal to 2 pi over b. And the pen on Sketchpad is not too good, but 2 pi over b is how I'm going to calculate my period. Where am I getting the 2 pi from? That's the period of the original sine curve, right? And so I'm adjusting here. So I have to, and I'm dividing by b because, right? X's behave inversely, right? B is a coefficient. I'm actually going to use it as a divisor. If I make b small, like 1/2, okay? If I make b 0.5, close enough. Now look at where I'm ending. I'm off by a tiny bit, but you see that I'm ending at 4 pi now, right? Oh, so what did I have before? I can write this. I had 2 pi over 2 before, right? I changed b to 2, and that gave me a period of pi. So I saw the whole thing end at pi, right? And when I have 2 pi over a half, like I have now, right? I end up getting 4 pi, right? My pen's just not working good on Sketchpad. But okay, what else changes, though, when I change b? What else are you noticing changes?
The quarter step.
Quarter step. So I'm going to have to, after I get my period, I'm going to have to think about how big is each quarter step. And then if I have a value of c that changes my starting position, now I have to think about where I'm starting and then walk my quarter steps. I like to say I'm taking steps. I'm taking 4 steps. So I have to find out where to start and then take my 4 steps. And the book is calling these the 5 essential points of the curve: the start, each of the quarter steps, right, the end, etc. And then where your critical values are, right? Where your zeros are, where your maxes are, where your mins are. Okay, let's look at the process, do a couple of problems. I know this is a lot, but at least it's the last thing. And then we start chapter 7 on Monday, and we're going to start, there's 2 topics of review from 098. And then in my opinion, the rest is fun. It's a good puzzle. Solving trig equations, proving trig identities. I think all of that's fun. So I really, sometimes you learn something and then you start learning new stuff that's not on the test, and students go, oh my God, don't do that to me. I don't think this will, I think it's just going to reinforce your knowledge of the trig and the properties of the trig functions as we're doing chapter 7 next week. Okay. There's my protector dog. Can you hear the dog in the background?
Can't really miss it.
Yep.
Her name is Lucy, and she sheds a lot. So I'm always mad that there's hair all over the place. So I call her Lucifer.
That is by far the best thing I've learned in this class today.
Oh, stop. Okay. Today, okay, that's fine. Today is fine. Here we go. I wanna just look at something with a phase shift. I think the amplitude is easy. I think the starting point is easy. I think the midline is easy. I want to just start with a shift left or right and see what happens. Okay. So I want to look at sine of x minus pi over 3. I can see that a is 1. I always want to kind of do this in order. Okay, my amplitude is 1, right? What's the value of b?
1.
1. So right away, I should be able to talk about the period. Is everybody okay with the b value being 1?
Yeah. Because it's just
For that, you just look at the coefficient.
Looking
of
at
that,
that leading coefficient, exactly. If the leading coefficient is not 1, I want to factor it out. I always want to get things in this form. Okay, I want to get things in that form. You don't have to do it that way. Some teachers will teach without factoring out that value of b. I like to factor out that value of b. I think it makes each step much simpler. I want to get my quarter steps right away, and I can get the size of 1/4 by taking the period over, right? I take the period over 4. So I do the period divided by 4. And it makes sense, right? Dividing by 4 cuts it in quarters, right? So 2 pi over 4 for us is going to be our pi over 2. Now, that's going to change when we change b, right? But right for now, b is 1, right? But I want to be able to figure out how big each step is. And I want to find my start. And I'm doing this process every time I do one of these problems. Going to find the amplitude, going to find the frequency, going to find the period, going to find the size of the quarter step, going to find the start, and then I'm going to use my knowledge of chapter 12 and arithmetic sequences to be able to write out my steps, right? So where's my start? Where is that phase shift?
Pi over 3.
Pi over 3. Again, what am I thinking for that green piece in there? Joe, don't answer for me. What am I thinking for that green piece in there? What x makes it?
Station.
Say it again, Alan.
Station.
Yes, but what x makes that interior? I'm leaving it blank. What x value makes the interior what?
0.
0. Nice. And yes, Alan, it is the phase shift, right? And so you would be thinking, oh, it's negative pi over 3, but remember, it's an interior. We're thinking x's are behaving inversely. So my start is done. I want to take my first step, right? I want to take my first step. So I start at the start, and then add my quarter step. So I'm doing pi over 3 plus the pi over 2. I want to simplify this. I know I'm adding pi over 2 every time. So once I figure out the first step, I can use my knowledge of those arithmetic sequences and know the rest of the steps instantly. So I want to simplify this. What do I get for my first step? It's 2 pi over 6 plus 3 pi over 6. So 5 pi over 6. I want to convert my start into pi over 6, and that's 2 pi over 6, right? Do we agree with that? You see my start and my first step?
Yeah.
Brandon, nice.
Yeah.
Anybody else? Grace? Diaja?
I get it.
Nice. So now I can see.
Sorry, Professor.
Go ahead.
I don't get it.
Okay, so you agree with the start.
Yeah.
Okay,
Yeah,
good.
yeah.
You agree with the first step. Wherever I'm starting from, I gotta take my quarter step of pi over 2.
Oh, okay.
Okay.
Why do you need to take your quarter step?
Remember, because we're gonna do that, right? We're gonna find our start, right, and then we're gonna move our 1, 2, 3 quarter steps so that we can draw that sine curve. Oops, what did I do? You know what I mean?
Yep.
I just go too fast, right? But I once I get my start, I want my quarter steps 1, 2, 3, 4, and then I know my pattern of where the sine, right, where that sine curve is going to be.
Okay.
Okay, so I purposely translated it into the same denominators because now I can just see what am I adding upstairs? What am I adding upstairs in the numerator? To get from my start to my first step, what am I adding in the numerator?
Plus 5.
Not plus 5.
5 pi.
Not 5 pi. I like the pi in there better.
Pi.
Some multiple of pi.
Oh, 3 pi.
3 pi. So the next one's going to be 8 pi over 6, 11 pi over 6, 14 pi over 6. I know it's arithmetic. I know I'm adding the same thing every time. So once I see what I'm adding to the first term, I get what I add to the second term, to the third term, and then those are my quarter steps. This is my start, and these are my quarter steps. So now I'm ready.
Oh, okay.
Now I'm ready to graph it. Once I have all this done, and well, D for me is 0 here, right? So I already know there is the midline is just the x-axis. I don't have to shift it up or down. So, but I'm ready to start graphing, right? So, and you can see where am I starting at 2 pi over 6. So I really want to start at pi over 6 because then I want a 2 pi over 6, 3, 4, 5 pi over 6, 6, 7, 8 pi over 6, 9, 10, 11 pi over 6. And I need one more, right? Yeah, 14, 12, 13, 14 pi over 6. And so I know my amplitude is 1. So I've got my box here now. And I've got my quarter steps. And I know sine starts at 0, goes to 1, back to 0, down to -1, back to 0. And there's my curve. So that process every time you're gonna have one question like it. Let's do another one. How we doing? We okay?
Yeah. Processing.
I know it's complicated. It's tough. It's tough. Read the book. Process. It's a little bit more convoluted, right? So I've tried to, in some 20 years of teaching this, try to just keep making it as simple as I can. And
This
it's
is
not
the only part of trig I was able to understand my first time around.
good. That's good. Let's do another one. Let's do one that's got a b value different than 1 in it. Okay. By the way, I do have the book here. I am showing the problems I want you to do in 6-6 here. So if you want to take a quick photo of that, I'd say 3 to 14. If you can do 3 to 14, you can answer the one I'm going to give you on the test. And how are you going to know if you're right? You're going to graph it in your calculator, right? You don't need to look at the back of the book to see if you're right. But the process is exactly my process. Find A, find B, find the period, find the quarter step, size of a quarter step, find the start, find the first step, then find all the remaining steps using the arithmetic sequence, then find your midline, draw the box, draw the curve, label the points. Right? I didn't label the points. I'll do that on this one. So let's do y equals 3 times sine of 2 times x minus pi over 4 all plus, not pi over, let me do pi over 3 again. All plus 0. So no.
Professor?
Yes, Grace.
Oh, sorry.
No problem.
I didn't get a chance to finish drawing
No problem.
the curve.
Yes, no problem. Let me get back there. And you notice that some of my steps will reduce, but I don't bother reducing. I want to see everyone in the same family, right? So pi over 6 is. And I want to scale it, right? So I'm keeping my pi over 6 steps all the same size.
Thank you.
Yes, you got it. Nice. What's our amplitude?
3.
3. So I already know, right? And I like to do this. I already know that my mother function sine curve, right? So the original sine curve here in black, 0, 1, 0, -1, 0, is now going to be all stretched out right here. So it's a height of 3 instead of a height of 1. But and you can see how quick I'm doing that because I know the shape of the curve. I know my quarter. I know the how it behaves, right? So I can really think of these things as quickly. But b is 2 here. So what's going to happen to the period?
The period length will be pi.
Yep. So I get 2 pi over 2, which is pi. And now my quarter step is how long?
Pi over 4.
Pi over 4. I'm always going to take that period and cut it into 4 pieces. So I know every time I'm moving by pi over 4. Where is my start?
Over 3.
Pi over 3. Everybody's here with me. Yes, everybody's okay?
Yes.
I'm trying to get this thing to all be super simple steps as we go, right? And so now I want to take my first step, right? So my first step is going to be pi over 3 plus the pi over 4, right? I do my start plus the quarter step. And it looks like I get 7 pi over 12.
7 pi over 12.
Yep. Which means I want to convert my start to a pi over 12. So what do I get? 4 pi over 12. And you can see that I'm adding 3 pi over 12. Coincidence, by the way. Just because I used pi over 3 again. But I'm adding 3 pi over 12 each time, so I got all of my steps, right? So start and steps is going to be 4 pi over 12 is my start. Then I step my first quarter step to 7 pi over 12, then to 10 pi over 12, then to 13 pi over 12, finally to 16 pi over 12. Always that easy. I'm now ready. Yes, and
how did you? Sorry to interrupt. How
No,
did
no.
you determine that your quarter steps were pi over 4?
Yeah, I got the period and then divided them by 4. That's all it means is a quarter, right? Divided by 4, and you got a quarter.
Oh, okay.
Every time.
Okay.
How do you got 4 pi over 12? Like, how do you know it was 4 pi over
So I got my start at pi over 3, but once I took my first step, I was in the pi over 12 universe. So I want to get my start in that same language. I want my start to be in pi over 12s as well.
But
So now that I have my start in pi over 12 and my first step in pi over 12, I can see the arithmetic sequence. I just have to add 3 pi every time. So I know I'm starting at 4 pi over 12, then to 7 pi over 12, then to 10 pi over 12, then to 13 pi over 12, and I end at 16 pi over 12. I certainly could to check another one, right? I could take my first step, 7 pi over 12, and add another pi over 4, right? My quarter step was pi over 4. And so that's 7 pi over 12 plus 3 pi over 12. So there's my 10 pi over 12. But I'm saying you don't need to do, this is why we did all that horrible stuff in chapter 12 with the sequences of series. So when we got here, we didn't have to think. We could just be robots.
I'm just confused how you got 3 pi over 12. Like,
Yeah. So where I didn't get a 3 pi over 12, right? I had a pi over 3 as a start, right? And then I took my start and added my quarter step, got LCDs,
yeah.
right? And got a 7 pi over 12. And then I said, okay, I better convert this to 7 pi over. I better convert this to a pi over 12. So I multiplied by 4 and 4. So downstairs multiplies to 12, upstairs.
Oh, okay.
Yes,
now,
yes.
That's
Yep,
perfect.
yep.
Thank you.
Yep. Good. I'm ready to draw the box, right?
Yeah.
I'm ready to draw the box. My midline is 0. I usually will keep the midline 0 on your test. But I know I have to start at 4 pi over 12, so I want to make sure I grid accordingly. 1, 2, 3. There's my 4 pi over 12. There's my start. I need 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pi over 12. I'm trying to be quick and neat. I know my amplitude is 3, so I can see where this box lives now, and my quarter steps, and I know the general shape of the sine curve. Done. What do you think?
It seems simple, but might take a little bit of practice.
Yes, you must practice.
But once you start doing it's you can do it just by looking at the original equation. It really is easy.
Yeah, it is.
Yeah.
I mean, brushing your teeth is easy, but telling you how to do it is impossible. Right? It's impossible. It's just so many steps. They're all so simple. Right? Nice, Sean. Yep, lots of practice. Just have to practice, right? And again, I like these problems from the book. Here, problems 3 to 14. Now let me show you how I put that one in my calculator, because I want you to see it. Okay. So, and it's a little strange. You just have to practice with the calculator. It's hard to see the box sometimes, but the key is going to be how you scale the grid. And so in y equal, I'm putting that 3 times the sine of 2 parenthesis x minus pi over 3. Oops. I like to zoom trig here. So zoom 7. And I got something wrong. Whenever you have an error, oh, I have this exponent here I have to clear. Damn it. 3 times sine of 2 times parenthesis x minus pi divided by 3. There it is. And zoom 7. So zoom 7 will give you a nice picture of the trig, and you can certainly see the amplitude of 3 here, right? I want to change my, is everybody okay here? I don't want to go too fast here. I want to change my grid, so I go to Window, and I see that I want to be moving by quarter steps, right? I really want to be moving by my quarter steps, right? And I want to start at my min, right? What was my min?
4 over 3.
4 pi over...
Pi over 12.
4 pi over 12, right? So I want to start at my minimum, 4 times pi divided by 12. And I want my x max to be where I ended, right? Where did I end? I ended at, remind me please, 16?
16? Yeah, 16
pi over 12. So 16 times pi divided by 12. Again, we know that reduces. And then I want my tick marks at my quarter steps, right? So right, I should scale this probably just to my quarter steps, which is a pi over 12. So pi divided by 12. And that should give me a pretty decent graph. And you can see my first quarter step is 3 of those tick marks, right? And so that's the idea. And then of course I can just go zoom zoom trig. So it's a little bit harder to see that particular thing, but you certainly can see it. I don't know if you can see. Can you see my mouse hovering on the screen?
Yeah.
That's my start, right? Up, 0, -1, 0. That's my end, right? That's the sine curve there.
So this might be